Hello, and welcome to another FHIR for Developers tutorial video. My name is Gino Canessa, and today this is actually take 2 of the continuation of profiling in C#. There was apparently a problem with my audio setup earlier that I didn't notice, so this will be a first in trying to re-record a video and hopefully cover the exact same content so that everything stays in sync. But with that said, we're going to pick up where we left off in the previous video, which is that we had everything working with the implementation guide and profile we wanted to use, but the code was a bit clunky still, pretty rough around the edges. And today we're going to see if we can make some quality of life improvements, make it a little easier to use, a little easier to move forward, and then in the next set we'll try to see if we can automate some of those pieces to make it even easier to do. So that said, there's a lot to do. Let's jump right in. I have here the project open, and this is the VS Code or the terminal for the same. I don't know what state all of my NuGet packages are in, and I think this is a good thing to test to show everyone anyway. I've been playing around with Git trying to reset back to something that's already been committed and all these things. But really what I'm going to do here is just do .NET list package first. And so you can see, yes, so this would be, when I tried to run it would not be happy. And that's because I have different versions installed and resolved right now. So if you ever get into this state, and if we try to run, we'll see all kinds of weird behaviors because it's thinks different things are installed than actually are. And this is because the packages aren't installed or aren't tracked in Git, and so the actual package files aren't there, but the package references are. So the easiest way I've found to fix this is actually just to reinstall the package. And so when it does that, it goes and fixes all the references, makes sure that everything's installed properly, and we can just, since we have so few packages here, oops, as long as we type things properly, we can get that done. Perfect. So now we have the packages running, and we should have our program here that is where we left it last time. And just to make sure, we can hit F5, and we should see everything run. Let's give it a second, and we can see our operation outcome here that everything validated. So we can still see it output everything and did everything. Perfect. So before we move on, I do want to fix, we had taken some shortcuts here just in the name of convenience last time, as far as trying to discover where things were and do everything. But I'm not a huge fan of how it is, and this file's not in Git, and so it was already set the way we wanted it to be, instead of the way it's supposed to be. So this is what we had in here previously, and it's a pretty default setup of what it is. But if we look in our program, we did set up, using that dragon fruit package, all of these nice command line parameters that we can pass in. And so let's fix the formatting too while we're here. So in here we're using the standard variable naming conventions in C#, which is Pascal case, I believe, because camel case is initial capital. If I remember, I always get those two swapped, Pascal case and camel case. But they're joined, and here. When we actually use them in command line arguments, they get automatically switched into kind of the Unix style, so -- word, and then they're hyphenated. In this launch.json, if you haven't played with it in VS Code, you can use these kind of strangely interpolated strings, and you can see they're more like the JavaScript style, which makes sense if you know, if you look at how everything's implemented here. But we can pass it, and it will expand this at runtime when it's passing these arguments in. So with that, we can get rid of the command, and we can pass in the patient JSON file name, the outcome JSON file name, and the profile directory we want to use. And that way we don't have to worry about where it's being run or anything like that. Same thing here. We can then clean up a little bit in our program and just say, you know what, by default, let's use the root directory wherever we're or the current directory wherever we're running, because we're not going to try and discover any of these things when we're actually running here. I was going to say let's run again, but before we do, let's do one more thing, and that is that right now we are displaying the outcome on the console, and I think it would be nice if we also displayed the patient on the console, and that way we can see the patient JSON file that we're creating as well, just when we run. Because especially in this case that it passed validation, that doesn't tell us much. And perfect. That is everything. So now we're in what I feel is a pretty good place to say let's pick up and start from. So let's look at what we're doing. Here we're creating a patient, and because we want to use this US core patient, and let's see if I have any of these windows here. I do. Outstanding. We need to pull this URL. And again, we just did a search for FHIR US core, and then from there we looked at the profiles, and from the profiles we looked at the patient profile, and that brings us here. So we can grab, you can see the actual URLs here, and this is the URL that you have to use to say this resource is supposed to conform to this profile. And so here we put it in as you're supposed to in the resource meta profile, and you have to copy and make sure that's in there and case sensitive and all these things. That's pretty prone to error, so let's fix it. We'll start by making a new folder, US core, so that we can put some files in it. And we'll start by putting a US core patient. That sounds pretty reasonable place to start. And just for simplicity, we're going to copy this as our starting point. And we'll put this same thing, since we put it in a folder, let's put it in there. But we're not going to be doing I/O, and we're not going to be doing serialization or any specification work here. That can all stay in the normal one. Perfect. So we'll go ahead and start with some sort of patient. I'm going to go ahead and make a static class, and that's because I don't want instances of any of this, and there's actually something nice that we'll do here in a little bit that takes advantage of that. But we already have the patient object, and we don't want extra copies of it floating around. And this kind of forces us into that model of thinking about, well, we don't have our own instance to play with. So I think that's a good place to start. Let's put some comments here so that the linters stop yelling at us. US core patient objects. And then what I like to do is actually grab from the web page, not this URL, but the URL of the web page, and just put that here so that later on we can control click if we want to find it. And if we also generate any documents, if you use redoc or anything like that that makes these XML comments into nice documentation, then these links will get propagated through, and that makes life better for everybody. So if we come back here, and let's hide that for a minute so we have a little more code space to work with, we can come back and grab our URL, and we can do step 1, which is just something like public const string profile URL, and put this here. Oh, and I have some sort of extension or something that's blocking that from working properly on these, so let's just do that. Perfect. And this, did we have a nice comment here? No, not really. But I think there's one. Yeah, official URL for this profile. So we can just put the official URL for the US for patient profile used to assert conformance. Perfect. So now, instead of having this string in here, we can do something like uscore.uscorepatient profile URL. And if we run this, we should still get the same patient that passes validation, and we can see our profile. Now this is great. It's definitely better to be using a constant that we can reuse and everything else and have it isolated in this US core patient information. But it's still pretty awkward that we are, every time we create a patient in this case, we need to go through and add a meta element and add this profile element and check the list and do all of these things. So I think it would be nice to move all of this information into here as well. So let's start with a function. And we'll we'll just start it and just do something like set profile conformance. Right? That seems like, again, a reasonable place to start. We definitely know we're going to need a patient object. And we can go ahead and do something like, let's say if we want to add conformance, and we'll default to true for that. And so this will give us a way to add this, but I think it's probably useful if we have a way to remove it as well. And so this is really, we could just say add profile conformance and remove profile conformance, but I like this model a little better. Let's fix our tabs here. Perfect. And there. And that is working here. So this is set or clear assertion that a patient object conforms to the US core patient profile. Perfect. True to add, false to remove. Pretty basic comments, but we're describing as we go, and they're fairly self-documenting anyway. So the first thing we're going to want to do is check to make sure we actually are getting a valid patient. And again, I don't try to go too far into all of the production things here in case it makes things harder. But in this case, I think it's important. I'm always a fan of doing null checks at the beginnings of things like this. So what we want to do here is just check to see if the patient is null. And if it is, we'll just throw an argument null exception with the name of patient. So the most basic of checks to see what we're trying to do. Now first, let's start with just adding the conformance, and then we'll add in the code to do the rest later. So we need to check for a meta, and then we need to check for the profile, and then we can check this URL. So first, we know there's a patient, but we don't know if there's a meta. This is simple enough because we can just say meta equals a new meta. And we could go ahead and add it here, but then we're just going to be repeating the code that we're going to add right below it. So that doesn't make too much sense to me right now. Below this, if there we need to check to see the same type of thing for profile. Now, I do want to highlight here because you can see there's profile and profile element. And I don't think we've talked about this before. So all I did here was hit F12 to jump into the definitions. And this is the metadata that's loaded from the .NET library. in this case, we can see there's two. There's the profile and the profile element that we were just seeing. Now, profile element, we can see this is a list of FHIR URIs. So it's got a nice FHIR data type. It has all these extra annotations here. So profile, that's the actual name of the element in FHIR that we're using, if it should be included in summary views, and then this ordering is actually for the XML file structure to make sure the fields are in the correct order. It also goes through here and says, the declared data types internally, when it was added to FHIR, that this is a data member, the cardinality, all the things you would expect from a FHIR element definition. When we look at the poor profile, all we see is ignore data member and IEnumerable string. And so what this is essentially, this is the convenience access into this. That we don't necessarily want to be using FHIR URIs and caring about all these extra things. If we just want some sort of IEnumerable, for instance, a list of strings, this is a much easier way to access it. So either one works, but you definitely want to stick with one or the other. There's some points where it'll propagate back and forth, but it's not, if you're going line by line, you might miss it. So in this case, we'll just use the profile, and we'll say if it's null, or if the count is equal to 0. Now we can see the count's not working, and that's because this is an IEnumerable instead of a list directly. And the easiest way to fix that is to add link, and then change this to a function. So this will work on, oops, did I add too many? Oh, there we go. No, it's cleaning that. Whenever you're using link, I always advise caution, just as far as understanding what's going on behind the scenes, if you will. In this case, it's just a convenience wrapper to say length of an array, the count of a list, whatever it is. But in only extreme cases would it actually go and traverse the list and count the elements. And I'm trying to think of a data structure that it would do that for that doesn't keep track of that internally. I'm wondering if maybe a stack or a queue doesn't have that. But for anything that has a count, it will just forward that call there and bring it back. So I'm not worried about expanding our list here, but it's just worth being aware of. So in this case, if we add, or if we don't have a profile, or if the count is 0 elements, we can go ahead and say patient.meta.profile is a new list of strings there. And we can actually probably go one step further and say, yeah, if we're doing this, we can go ahead and say, just add the profile URL here. And return, because we're done. We've already added it, we've created the meta here, and that's it. Because the next ones will get more complicated if we want to add it here. So, what else do we need to do? Now we're saying we already have a list, and we need to check to see if it's in that list. So same thing, we can just do patient.meta.profile.contains, and we can see that this is again doing a link function, but again this is just going to do equality checking across these units, and it's a string comparison, so I'm not overly concerned, and particularly because the profile element is never going to have many values. And so I'm not worried about using it in this case. And if we contain the profile, we're already happy. And if we don't, we just do patient.meta, profile at, and append the profile URL. Perfect. So this would take care of adding it. So this is what we want whenever we're doing add conformance equals true. And then we can go ahead and add when we want to remove it. Now that should make sense here. So if, for instance, the patient.meta is null, if we are not adding conformance, we can return. We have nothing to remove if there's no meta. Same thing we do here. If we're not adding conformance, then we don't have to create a new profile or anything else, or create the new meta profile element. We can just return. Now, this is where it gets a little different. If we are not adding and we have it, then we want to remove, and we're still in here, so here we'll just cast it as a list of strings because we know that's what it is. And it's a list of strings, which is patient.meta.profile, and then we can remove the profile URL. So here we know that it is a list of strings internally from the structure of the FHIR libraries, the FHIRnet API, and we also add it here if we do it that way too. And so we know that we can just remove it. Perfect. So if we're not adding conformance, we remove it, and if we are, we do that, and either way we're done. Perfect. So let's see what happens. Like all good live coding exercises, let's come down here before we serialize so that we're doing all these in one place. And what do we need to do? We need to do a uscore.uscore patient, and we want to set profile conformance to our patient, and we want to add it. So if we hit F5 now, we see our patient that was being exported here, written on the console, and we can see meta profile with the patient here. That's good. We should be able to say false and hit F5. And if we run it this way, and here it is yelling at us because it's not actually a list. Huh, interesting. I thought it was a list internally. So there you go, the beauty of live coding, even on the second run through. So in this case, what we need to just do is do something like there is no remove from IEnumerable. So we can do something like list of string temp equals patient.meta.profile.as list. I thought there was an as list here. I'm trying to remember how I did this the first time around, and I am blanking a little bit, so you'll have to bear with me here. That's what I get for recording it so late at night as well. So let's actually put I'm curious if we can use this. I think I might have used profile element last time, which lets you remove, but it only does that. So we can do this. We find an index, so we start at 0, and profile. So for each string profile in patient.meta.profile, we want to say if profile equals profile URL And that way we can ask it for string comparison ordinal, because we know these are there. Then we say break, and here we say index plus plus. And then we should be able to, this is kind of an awkward way of doing it. But let's see what happens. Yeah, we're having fun with this. So remove at, and we can say index. And I'm not sure if these will be synchronized after at this point or not. So that's why I'm kind of curious here. So let's see what happens. So when we look at patient, there we go. We have it in the watch here. We have patient. And let's make this a little bigger so we can see what's going on a little better. We have patient meta profile, and it has one element. And we can't see much of anything from it. And profile element has the FHIR URI. So, and we can see that one. So if we try and remove it, that seems to have worked properly. Perfect. There we go. So we can get rid of our debugger there, and we can see we've removed it. And in this case, it's saying that the element can't be empty because patient.meta has nothing in it. So if we want to go and add all of this, I don't know that we want to add it in this case because it's just a lot of cleanup. But really what we need to do is check to see if meta has no other fields present. And then if that's the case, we need to remove the meta altogether. In our case, since we know that it's all we added, we could just remove it. But I think that sounds like the great kind of thing to do either out of sequence or as an exercise. So really that's what it's complaining about. It's pretty straightforward there to just check across to see if there's anything else in meta and go through all of that. But in reality, we're not going to be running into that. The other thing we could do is if we want to, we can just say as a stopgap, if we're removing the element and the new count is zero, then we can just go ahead and do something like last updated equals, and it's a date time offset, so I think the right way to do it is now. And actually we can just add that always when we do this, and then we don't have to worry about anything we want to do in here. And anytime we add the meta, so at this point we know we have a meta, and we can just say set last updated so that meta is never empty. And then here, I don't know if we have to remove the profile element altogether. Let's see what it complains about. Nope, that's it. So in this case, we just said, all right, we'll just add the last updated field, which is when the version was last changed. And we are updating it. So that's a perfectly fair way of getting around that problem. Oops. We weren't testing removing it. Let's make sure that that happens. We want to make sure our code is working when we commit it back. Perfect. So we can now add and remove the profile, but we want to make this just a little bit easier to use too. Right now we're passing in all of these things, and as I said, by using these static classes and static functions, we can do something fun in C#. And that is this. By adding the this keyword here to the first argument here, which is a patient, what we're actually doing is telling Roslyn, the internals, that this is supposed to be an extension on top of the patient object. So we actually need to rename it a little bit just so that it's not too crazy. And we can probably get rid of this because our name's getting too long. When we do this, instead of calling across here, the first thing we need to do is actually add using FHIR CS Basic US Core. So we add that to our usings. And the nice thing now is we can just do patient.usCore set patient profile. And that is an optional parameter, so we can even do this and it will add it. There we go. So now, if we run, it does the same thing, but we can see this is going to help us organize all of these things a lot better. We can start putting in things like US Core patient on patient. And as long as our naming convention stays somewhat sane, they'll be very easy to discover in our code and very easy to use in our code as well. So this is great. We can go and add and remove our US Core patient, but we still have a lot of things here. So let's go through and do the same thing for US Core birth sex. We'll go ahead and add our new file. And we'll actually copy some of this from US Core patient instead, because we can copy all the way to there, I think. And perfect. So we want to do the same thing that we were doing here. We can see if we look at the US Core birth sex, we can get the extension. And let's go ahead and put that URL in the documentation. So we update this and class with, and now we can actually change both of these for the, so with patient extensions for the US Core birth sex extension. We should update the documentation here. These aren't utility functions. These are patient extensions. Perfect. So, and I did mention, just to make sure, since I've done this now a couple of times, we need these to be in static classes, and these need to be static functions in order for all the extension mechanism to work, if I remember correctly here. So we need to do some of the same things we were doing before, right? The first thing we can grab is our public const string extension URL, and we can put that here. And I know that it's not going to work if I just type my / for some reason, so I'll go ahead and clean that up. And US Core birth sex extension. And this isn't about conformance, this is now we need this in order to actually use the extension. So here we're going to need to make a function similar to this US Core patient set profile. We can get that started. So we want to name these all starting prefixed with US Core so that they show up together when we are looking for code completion. And then we can go ahead and use birth sex set. We can do something like this. And so that will allow us to do a set on the birth sex, and it kind of gives us that pattern, just like if we were doing these hierarchical clean classes. You know, we would have, it would really be us.core.birthsex, and then we would have a getter and a setter. We'll start with the setter because that makes more sense, I think, to me. And we're going to do the same thing here, that we want a patient. But in this case, we need to take in this code that we're going to be doing. And that's just a code, and we'll call it birth sex. Perfect. So we can say set the US core birth sex on a patient object null to remove. And since code is nullable, that's pretty easy to check, and we can just say if you pass in a null, we'll remove what's there. If you wanted to instead, you could do something like US core birth sex remove or clear or different things like that, but we don't need to worry about that right here. Part of that, again, and this is important to look at, is US core birth sex is a 0 to 1 cardinality. So we can have 0 of them or 1 of them, but we can't have 2 or 3 or 4 of them. If you can, then you might want a slightly different model here, which we'll get into later. So really we want to do the same thing here, do a null check first. Again, these really shouldn't be happening because they're pretty difficult, especially on extensions to do, but you can do things like patient p null equals null, and then now we can say p null dot US core, and we can call this function here. So we would get a null value that way. It's unlikely, it can happen by accident and things like that, and this is a pretty lightweight check to do on functions like this. So it's not a terrible thing to do. Now when we start looking at extensions, we have this extension, but what's nice is that this is a list of extensions, but if we start looking at what we type, we can see there's lots of convenience functions that they've added to the library. So we can see there's add extension, get extension, remove extension, all these different things that we can use to make our life easier than just using a list of extensions. So the first thing we'll want to check is see if we're removing it, in this case, I think, because that'll be easier to separate out. So if birth sex is null, we want to remove. And again, what's nice is there is a function called remove extension. And you can see it actually removes all extensions with the current URI, if any. So all we really have to do is pass in this extension URL, and we're done. So if there are any US core birth sex patient records extensions on this patient, this will go ahead and remove it. And if there aren't any, it won't do anything. Either way, we're happy because we've removed it. Once that's done, the only thing we have left is we know this isn't null, and we know that we want to add something. So we can just do the kind of opposite call, which we can look here. Now we have a couple of options. There's add extension, which adds a new extension with the URI and value. But there's also set extension. And set extension will add an extension with a given URI and value, but remove any pre-existing ones. And if you don't want to read through all the tooltips, you can also just, again, hit F12 by default, obviously, if you've remapped it. And you can see that these are all documented here. And this is just the API documentation. You can find it online as well. But once I'm in the editor, I like staying in the editor. Actually, let me close this so we have a little more screen real estate here. But you can see, you can scroll through these and read what the documentation says and how these are grouped together. You can get a lot of information by reading that as well. So in this case, we're just going to go ahead and set the extension based on our extension URL, and we'll pass it in the birth sex that we have. Done. So now we can come back here, and instead of taking this extension on the patient and keeping track of the URL and knowing where it goes and everything else, just like we added this, we can say add a US core birth sex. And we can say birth sex set and pass it our code. So if we run this, we see it validated properly, and we can see here is our US core birth sex with an unknown code. Now, that's obviously far better. We know that we need to pass in a code. So that was one of our problems we had with the extensions, right? When you talk about extensions up here, like here, when we just add a new extension, it could be a coding, it could be a FHIR string, it could be a FHIR URI, it could be a code, it could be any number of things. And there's really no type hinting. So while this gives us code, it still doesn't help a ton. You can see we manually just typed in this unknown. We could go and say, let's type in what the genders are that are allowed in birth sex. And if we go and look, we can see that there's a value set for them. And it actually only has 3 values, F, M, and this unknown. We can also see that it is a required binding. And I don't know if we've talked about this in any of these videos yet, so we'll quickly divert here. I know it's getting long, so we won't do it too much. But when you have a value set that's being bound to an element, there's a binding strength that's attached to it. And you can see there's 4 values that can be in here: required, extensible, preferred, and example. Required, which is the one we're dealing with right now, is just saying these are the only values. That's it. So if you want to use US core birth sex, you have 3 values to choose from, and it must be one of those. You can't add your own, you can't bind to something else, you have to use a different field for that. If, for instance, this instead of required said extensible, then you could say, okay, well, yes, here are the 3 that we've provided, but if you're trying to represent something that's not there, you can add that. So again, you wouldn't apply US core birth sex like this, but if you said you were applying it, you might, to a certain species of animal or some other type of thing like that that's born ungendered. So it's not female, it's not male, it's not unknown. Okay, we need to add something else. You would be allowed to do that if it were extensible. You are not allowed to do that because it's required. So just to be clear on that, so I don't confuse anybody on it. That said, in extensible, you could not add, if you wanted to actually write out the explicit female or male in your code system, you cannot do that, or put, whatever letters make more sense in a different language. You cannot do that in extensible because there's already a code there that represents that concept. In preferred, in preferred, you could actually do that. So if you said, well, in my language, it's not M and F, that doesn't make any sense. Those aren't the letters we use. Then you could change those in a preferred binding. An example is just the lowest, and that's just essentially saying, here's an element, here's what it should look like when you put a value set in here, but we can't define that value set for you. You need to define one. If you're talking about things, for instance, internal in a hospital, that they're defining within that hospital, there's no standard for it. You can just say, yes, you need to define it, and we're not going to worry about it. So anyway, thanks for allowing the quick diversion. No. But you can see here, we only have 3 values, and that's pretty easy to work with. So instead of saying we just have this arbitrary code, we can do something a little more fun. So in this case, we can take our US core birth sex, since we can go into the right file, and let's go ahead and add an enum. And we'll actually add female, male, and unknown, because we are looking for developer things. And we'll copy this because I know that my triple slash is not working properly here, but we'll go ahead and make these smaller. So we want to make sure we keep in mind that the actual code, the actual value is F here, and then we know that it's female. And then we can actually copy this and put an M here for male and a UNK for unknown. And while male and female are pretty self-explanatory, I will just copy this text from the birth sex web page. So that tells us a little more about what's going on. And let's add a comment here. And again, we can look on here for the value set and see if there's any good descriptions here. Ah, perfect. There is a good set of descriptions here. And we can put that there. And we can actually go ahead and grab this URL too. So same thing, gets propagated through all our documentation. Future you will always thank you for things like that. So now that we have this, we can change our function a little bit. Instead of passing in a code, we can pass in an enum, but we need to make it nullable. And the reason we want to make it nullable is the same thing, that we want null to remove it. So if we wanted to, we could just split this out into separate functions and then remove the null. I kind of actually like that better. So let's do that. We have the flexibility here. US core birth sex clear. And in this case, we still need this patient. And we'll just grab some of this code. And we don't have to check this. We don't need to explicitly return because we have that. And I don't know if I like clear. Let's do remove. And so here, clear a US, clear any existing US core birth sex extensions from a patient. Perfect. So now we can remove it, and here we need to change this code a little bit. We can't add this directly anymore, and we could try to do some different things with the annotations or looking up values, but at the end of the day, for me, I'm a big fan of simplicity for things like this. So let's just do a switch, and we can say each of these values, and we just grab them here and add back in these things. Now we can see we did put that actual code there so that we can help us remember what they are. And in this case, it's F, M, and UNK. And let's clean this up so it's a little easier to do. And then in it's an enum, so we don't have to worry about other values right now. Again, if we want to be extra cautious, depending on production code and things like that, you can add a default here that throws a warning saying that we found an unknown code and all that kind of thing. But I'm not overly worried about it here. So now we have a set. I can't decide on this. We'll go with clear. Set, clear, and we'll do a get here in a minute. But we can see we aren't allowed to use this unknown code anymore. and instead we have to use our enum. So this is a pretty big win as far as code hinting and type safety, because now we know we are setting only from our list of allowed values in here. And so if we hit F5 now, which always gives me a chance to take a drink, just water, we can see that our US core birth sex is set properly. And if we want to, we can change this to, for instance, male. And when we run this time, we can see that it has the value code of M, which is valid, and it does validate correctly. Perfect. So the only problem is now if we wanted to read this value, we don't really have any. Oh, we should actually try clearing it once before we even do that. So if we do that just to make sure that we did this properly, you can see that extension is not here. They're always sorted here, and correct. It did remove it as expected. So we don't want to remove it right now, but we would like to be able to read this back. So for completeness, let's go ahead and add that. So my preference when I'm doing something like this, and it's weird, I keep mistyping it one way or the other. In US Core, they have birth sex as one word, and so for me, I always feel like inserting casing on this, but this is the way they have it typed there. So we definitely need this patient, and we need an out US core birth sex values nullable birth sex. I like to use this try get model instead of just the get. I find that it's a little easier to work with. Again, that's preference. If you prefer just doing the get and throwing or returning null, different things like that, obviously, whatever style you prefer. But in this case, since I am coding, I will pick the one I like. We'll start by doing the same thing here and saying check for a null, and actually we will go ahead and try to get the US core birth sex from a patient object. True if value was read, false otherwise. Okay, so it's a standard try get. Oops, this is popping up here. Perfect. So with this, we need to, again, we can start by looking at extension. And just like above, we have all of our sets and our removes. We do have some other options. We know that there's going to be at most one, so get extension is likely going to be enough. So it's going to be return the first extension with the given URI or null if none was found. So that sounds exactly what we want. But we need something to hold it. Extension, we'll just use this for right now. So we want to see if there was no extension, or actually we need to check if there was no value in the extension. Neither one of these cases would be a valid element in the FHIR object here. So in either of these cases, we can just say birth sex is null and return false. So we know that in this case, if we didn't find one, or if we found one but there was no value attached to it, just we don't have anything to return. Now, if we look at the extension, this is, again, why we're doing this in these separate classes, is because we don't have any sort of type hinting. We know there's a value there, but that's all we know. The proper thing to do would probably be to check the type. You can either do that with a switch case and do typing, or there's different things like that. In this case, just as I look at the time for the video getting a little long, for this pass, and we can always clean it up later, we'll just know that it's a code and that's it. So in this case, we can just say value, and there's a code, and that's ext.value, because a code has another value inside of it, which is a string. So this value is going to be our actual codings, just like we created up here. So in this case, we have a case F, a case M, and a case unknown. And did not go at all. Okay. So in the case F, we want to say birth sex equals our female value. And we can go ahead and return, yeah, we can just leave the breaks for now. I was saying we could probably return trues, but really we can just fail out if it's unknown here. So we say here we set all of them, and if we've successfully done that, we can return true. Because in the default case, we are going to return false. And in this case, we will say birth sex equals null, so that that doesn't complain. So we'll read the code value, and if it's one of the ones we know about, we'll pass the appropriate enum, and if not, we will do false. So we can test it here. Same thing. We like to test these, whatever we are writing. And we will try get the birth sex, and we will say out US core birth sex values, and it's nullable. And if we get a value back, we can go ahead and write found US core birth sex and put the value. Perfect. So let's see what happens when we run it. We could see something came out here. Found US core birth sex unknown. And again, this is the beauty of using nicely typed things. If we were to change this to female this time, when we run this, just to make sure it's actually doing what we want, we can see that we got back our female. And if we want to, remove this, and let's put an else here just so we have something written, and we say US core birth sex not found. And when we run this, hopefully that's the message we see, and there it is, US core birth sex not found. Perfect. So I think we've established a pretty good pattern here. This segment's coming up on an hour now, so I think I might have to cut it out here after a quick review. But really what we're looking at is we can see we did the core profile, and we can set and remove that profile. And again, knowing that we ended up doing a set and clear function here, we might want to change this to do that. US core patient profile, yeah, we can rename this to be a little better. In fact, I will. We'll split it out into two functions, just so that things are more uniform. That actually simplifies our code quite a bit anyway. And then all we need is the patient. And we'll do the same thing here, that all we need is the patient. I said we were wrapping up, and that's what happens. So we want to clear this, and we can get rid of a lot of this extraneous code here, and update set last updated so that meta is never empty. That makes sense. If the profile is null, we are not adding conformance, so we can just return. And then if the meta profile has it, we need to go through our thing that removes it, and that's it. If it's not there, we don't have to do anything. And then same thing, we can set the assertion that this happens, and then we can clean up all this code. Deleting code feels nice. And so we make sure we don't over delete. Perfect. And we don't have to worry about doing this when we're adding anyway. Perfect. So now we have to fix this US core patient profile set. And then we set our birth sex, and then we try and get it. So I'm pretty happy with kind of this model of code. We can add and remove the profile. We can add and remove a simple extension. And it shouldn't be too hard to take this model and apply it to a complex extension. So you can see this is the same thing here that we were doing before about having the race extension, and you can see there's many values within it that we're adding. So we'll pick up next time with that one. But in the meantime, again, apologies for anyone who saw the earlier video posting with no audio. This one looks to be coming through properly. Won't get posted if it doesn't. If you like the content, please like, subscribe. It does help out, and I do appreciate it. If you have any questions, comments, or suggestions for future videos, again, please let me know as well, either on YouTube or on GitHub or on Zulip if you're there. So thanks again for watching, and cheers.